Hi, everyone, and welcome to this live event, Accelerate the Data Analytics Lifecycle with Unravel. I'm Clinton Ford, VP of Product Marketing here at Unravel, and I'm joined today by Sanjeev Mohan, Principal and Founder at SanjMo, Subramanian Iyer, the Unravel Training and Enablement Leader and Databricks Subject Matter Expert at Speedboat, and Don Hilborn, the Field CTO at Unravel Data. Great to have you with us here today.
Thanks, Clinton. Good to be here.
Thank you.
Thanks. So as you know, there's been a lot of increase in demand for data and for AI. We're seeing this pick up really across the board. And wanted to spend a few minutes, first of all, starting off on this topic, just to get your perspective on some of the key drivers happening out there in the landscape. So, for example, one question that I have for you is, from your perspective, what do you see as driving the demand for faster data life cycles? Going from, data ingestion and curation all the way to producing a model and then putting that into production. What's making that such a high pressure, high stakes situation right now in enterprises?
I think the key to success is consistently making good decisions. And the key to good decisions is good data, good information. And so all things being equal, the better information you have, the better decisions you will make. An analogy I sometimes use for this is, let's say that we had a choice of flying on one of two of the latest and greatest Boeing 787s. They've been maintained identically. The crews have been trained identically. Both planes are flying through the Himalayas at night, and the only difference is one has an altimeter that works and the other one doesn't. Of course, we all want to be on the plane with the altimeter that works. And the point being that given the same decision-making capabilities, an organization can be much more effective if it has the right data at the right time. And we're recognizing more and more that we can process these huge volumes of data and essentially make the entire data set available to decision makers. And I think they recognize with that, that's going to be a significant competitive differentiator for them.
Excellent. Sanjeev, you had a comment as well. What was your perspective on that?
I agree with everything Don says. What businesses really want is they want access to all data, like he said, and they want it when they are making decisions, not 24 hours later after the campaign's already over. Now you come back and tell me that these are the parameters, so it's too late. So the reason why businesses sometimes are unhappy with their data ecosystem or their data layout is because the time to decision is too long for them to stay competitive.
So I was going to say the same point. In fact, over the 7-8 years I've been in the industry in Spark, we've seen this big shift, right? It's gone from, let's do end of day batch. And now it's becoming like, there's a shift towards real time or near real time. And the time to insight has been steadily going down. It used to be end of day, then it became like every hour. Now they want every 15 minutes. Combine that with models. And now, you want execs asking real time, like a natural language question and getting an answer that is up to date, like 5 minutes ago, what's happening, right? So that's that. And the companies who get it right will survive, will thrive. And the ones that don't get it right will fall by the wayside. So that's the pressure that you talked about, Clinton.
Yeah, right? And if we translate this even into the cost, see, this is how things are so different now. I'll give you a funny example. Many of my colleagues, myself included, we've been guilty of running a Cartesian join in Oracle database in the past, where you have a 1,000,000 row table, 1,000,000 row, and you just join every column, so it just, in the past, what would that do to your database? It would bring it down to a crawl. The DBA would go find the errant SQL and kill it. And then we would be back to normal. What will happen today if you run it? We just get a $40,000 bill. So we have to be more real time. We have to know exactly what's happening at the time. And if something is an anomaly, then we want to act on it instantly and shut it down before the CFO gets a bill and all hell breaks loose.
Yeah, efficiency really is the new SLA. Go ahead, Don.
I was going to say one of the.
I cannot emphasize on that enough, because once upon, like in the old system, right, when it's on-prem, there is a natural constraint that you can't run up you can't have a bill bigger than your system is.
Right.
In the cloud, unfortunately, that constraint is not there, right? So you got to be extra vigilant in the cloud. Don, over to you.
No, I was just going to say, I think one of the biggest things that has changed is, and I think this was touched on by both Subbu and Sanjeev, is the amount of data. A lot of these models that we're using have been around since the 50s. And in fact, LLMs were first proposed in the 60s. What's changed is our ability to process these huge volumes of data. One of the things Google proved to the world was that if you could process all of the data, in their case, the internet, you could be the best search engine, period. And so Google actually maintains multiple copies of the internet. And one of the things it's been able to do from the onset is to go through and index that data using machine learning. And therefore, when you do a search, it comes back with a document or something that meets that search. What we're seeing with LLMs and generative AI is now even better than that. You can go ask it a question and it can come back to you with an answer, a human, what appears to be a human-like answer. And I think a lot of that's driven, and Subbu touched on this a little bit, is when we had data centers, we were kind of confined with whatever was in that data center. In fact, one of the ways I got into the big data space was I was faced with a problem where we had to index 6.5 petabytes of data and search it. And I went to my data team and I said, hey, how long will it take you to get this available to me? And they laughed me out of the data center, right? It wasn't something that they could make available, even if they had the room. But in the cloud, of course, in a matter of minutes, I could stand up a super environment that was capable of processing all of that data. And that was kind of the eye opener for me, that data centers were going to fall by the wayside. The economics are driving it, but also this ability to stand up a supercomputer that you never would have had in your data center and process these tremendous amounts of data is a big differentiator that companies are seeing they're able to do today, and it results in better decisions for them. So I think that's another thing driving the growing need of data and more data.
Excellent.
Every
go ahead, Sanjeev.
Small, medium-sized company today, on an average, according to many studies, have over 100 SaaS products. On an average, every company. If you're talking about a large company, you're talking about, on an average, 450 SaaS products. Imagine the amount of data that is being generated from these SaaS products. And the funny thing is, a lot of these SaaS, so I'm talking about SaaS products like, Marketo for marketing, or HubSpot, or Salesforce, obviously, all kinds of products have now come up. And the problem is that each one of them has its own data model, and that can change. When the new release comes, they can change it, because they're all experimenting. So many of these are new companies. So this is the explosion of data that we are ingesting. Now we have to analyze all of this data and find some nuggets of, like, what are the correlations between these different elements. And by the way, the schemas are all different. The semantic meanings are all different. And this is the reason why it is so expensive to build these so-called modern data stack. And hence cost is really high. I see this all the time. The CFO goes to the CDO and says, you invested $20 million. What did I get? A few reports and dashboards? It's very hard to determine because there's so much overhead trying to integrate all these data assets.
I think you touched on some really good points. This is what we see out there, right? People are drowning in data, starving for insights. I'm sure you've heard that before, right? And the fundamental reason why this is happening is because like you said, there's so many versions of the same data. Processing it, accounting for versions, massaging them into one canonical form, and then doing insights on it. That's the heavy lift.
Yeah.
That's where the bulk of the compute and the bulk of the developer effort goes in, right? Yeah. And that's just in batch. And now compound that with streaming for real time, and you get a sense of how hairy the whole thing gets, essentially.
Yeah. Now, Don, to your point, you talked a little bit earlier about everyone wanting the very latest and greatest product. So earlier this year, McKinsey published results from a survey that said 75% of respondents expect Gen AI to cause significant or disruptive change in the nature of their industry's competition in the next 3 years. So when it comes to generative AI, what is the key differentiator? What really helps one product stand out against another one? What is going to be that factor that makes one product better than the other?
I think it's ultimately the ability to access the relevant data and then give the most accurate answer. Yeah, I know that's somewhat oversimplified, but it does come down to that. And I think what all these industries are concerned with is they don't want to be disrupted, right? They don't want to be the next company that falls to Uber or to Airbnb or to LinkedIn or to Facebook. These companies have disrupted the way things are done in their industries, and they've all used data to do it. And you're right, now they see with generative AI, the threat is even more powerful. Not only are they using data, but now the AI itself is being used to help these companies make better decisions. And again, whoever makes the best decision most consistently will ultimately come out ahead, and companies know that. So I think that very simplistically, they'll be looking to generative AI that makes sure that it's considering all the relevant data and it's giving them the best answers possible. And then, of course, all the subtleties around ease of use and cost and other things will come into play. But I think those will be the biggest drivers that will ultimately drive the more successful generative AI platform.
Excellent. Subbu, you had a thought?
No, I'll let Sanjeev go.
Go ahead, Sanjeev.
Okay, thank you, Subbu. I'm an analyst. I like to talk, so you have to shut me up. Otherwise, I'm trained to do. I'm paid to do this stuff. But generative AI is a beast by itself. It has introduced some new kind of problems that we've never really had to deal with in the past. Mainly because an LLM or a foundation model is probabilistic, as opposed to SQL, which is deterministic. If I run a SQL statement, I will get the same response every single time. My data doesn't change. But if I ask a question to an LLM, it may give me a different answer. So the biggest problem that businesses face is hallucination. The second problem they face is security. How do we know that sensitive data is protected? You didn't train on data that wasn't masked. GDPR, data privacy protection, sovereignty, all of those things come in the picture. But the third thing that I want to talk about on this call, because we're talking about cost, FinOps, data observability, and that is a cost piece. So the cost of training the model is out of reach of pretty much any company in the world, unless you happen to be one of the hyperscalers or you've been hugely bankrolled by VCs, is hundreds of millions of dollars to keep these models trained. In fact, OpenAI, even with its billions of investment from Microsoft, is bleeding money. And I saw some report a week ago that they may run out of money by next year. So this is because that is the cost of training. And even the cost of inference is very high. When I run a Google query, it costs literally pennies, fractions of pennies to run that. But when you run a LLM query, it costs a lot of money. So businesses that want to use generative AI have to rethink the cost factor. What model should I use? Not every model is meant for every area. For like, you cannot use GPT-4 for every single thing. It's trained on public data. Maybe these are smaller domain-specific models. A model that's trained on text to generating Python code or SQL could be used for that purpose. A model that is meant for translating 100+ languages, use that for translation. So there will be a number of these LLMs, and that's a first step. We haven't
That's
even.
the first step.
Yeah, I'm going to stop here and let's.
No, I think you're going exactly where I was going to go, which is great because you're in my head literally, right? Is that as a practitioner, you got to make a bunch of choices, right? Like the success, the accuracy of your model depends on the base model you choose. So you have Mosaic, you have Dolly, you have Hugging Face has got a list of them, right? So to pick a base model, then you got to build your chain. You got to install the right agents, right? In LangChain, and then ultimately the data that you're feeding into the model matters, because if you feed it junk, your model's going to give you junk, right?
Garbage.
So then exactly garbage in, garbage out. So and that's where a huge part of the effort goes in for developers like me, right? To make sure that my data is clean, requires me to put all sorts of processing constraints. We touched on this earlier, right? We have all this different schemas, different versions, copies of data, reconciling it, cleaning, all that stuff is work.
Yeah.
And that is going to be the other frontier of cost overruns and blowouts.
I think data observability vendors, like most of us, we don't even know how and where this technology is going at this point. We just don't know. I mean, we're at such early stages, but data observability vendors are going to have a field day trying to figure out, the cost overruns, the quality, the latency going from different parts of this generative AI pipeline.
Absolutely.
Now, is all this data really structured data, or are you seeing a shift as well towards streaming or semi-structured or unstructured for these use cases? Let's start with Sanjeev.
So thank you for asking that, because I think, so like I mentioned, choosing your model is only one of many cost containment steps you can do. The second one is, what is your use case? In my opinion, and I'm making this prediction here on this webinar, is that in 2024, we will see the use cases that get funded and are deployed will be the ones where there is a very clear-cut ROI. For example, to answer your question, will it be structured, semi-structured data, streaming data? I think unstructured data is a clear-cut case, because what happens is that many organizations get PDF documents from Bloomberg, from Morgan Stanley, from Goldman Sachs, from all these places. Everyone is in a different format. A team is sitting there trying to decipher what's in each of these documents and then putting it manually inside a database. That is a ROI waiting to happen. It's like, if you can put an LLM that can intelligently do extraction of entities and then classify or tag them to have a common meaning, is going to be highly adopted. But if you have a use case where you are putting the LLM because you're making your developers more productive, the question will come up, how do you measure productivity? It's so hard. So how do you know that LLM is useful? So this is going to be the second important cost-related consideration for Gen AI.
And Subbu, what's your take on that, on the different types of data that you see demand for in terms of these, generative AI projects and other things like LLMs?
I think it's going to be all. I mean, I think every kind of data is going to get scraped up in this thing, right? It's going to get vacuumed up. With Lakehouse and Databricks, for example, we have opened the door to unstructured and semi-structured data. So JSON data, PDF, audio, video, binary, anything can be processed in Lakehouse, in Databricks very effectively. So I think you will see more and more of that for sure. Of course, structured is always there. That's the workhorse of the industry is structured data, right? So long story short, it's going to be all kinds of data.
It's going to be a combination. We are going to see a combination of operational use cases and analytical. We are already doing that. We call it HTAP. So OLTP and OLAP. Now it'll be OLTP, OLAP, predictive, and generative. And let me give you an example of what I mean by that. So let's say I want to find out which customers of mine have a propensity to churn and not renew their contract next year. Every major company has this problem. I can today either write a SQL statement and do a where clause where this is this, and I can generate a list. Or if I'm super smart in my company, I can do a machine learning model and I can do some sort of like, decision random forest or some sort of way to predict which customers are. So now I've done predictive and I've done my normal query. Where GenAI comes in the picture is that I'm going to do this kind of machine learning, find out, tell me the list of customers that may churn, and then I'm going to send that list to my LLM and say, for each one of these, generate, because it's generative AI, generate a action plan based on everything that you see about them in my database. And now I may have a separate plan for Don, separate for Subbu, separate for Clinton, separate for me. And the salesperson can now have a more precise, personalized plan of how to go and try to convince this customer to renew. So this generative piece never existed. That is a brand new. We're plugging it on top of everything that we are doing today.
Great. And Don, what are you seeing as you meet with customers? Are you seeing the variety of data proliferate as well?
Yeah, I think that's really where big data came into play, right? The three V's, the volume, velocity, or variety. And that was really how I got into the big data space. I primarily worked in structured data up to a point, but I happened to be working for an oil and gas company when one of our rigs, or at least a percentage of the rig we owned, blew up in the Gulf of Mexico and attracted a lot of attention. And what came out of that was a subpoena from Congress for us to go through about 6.5 petabytes of data and produce to them the results. And I mentioned that earlier, where I went to my data team and said, hey, what can you do for me? And they kind of laughed me out of the room. But I was able to take a bunch of small servers and wire them together using this newfangled tool called Hadoop. And I was able to look at the data regardless of whether it was structured, semi-structured, unstructured images. And in fact, the issue turned out to be an issue with a PDF and just an old PDF being used on the rig, which caused them to use a lighter cement than they were supposed to down the hole. But without that capability to process it regardless of the volume, velocity, and variety, we would have never come to that answer. And so I think big data has been about the three V's for a while, but what we're seeing is, of course, AI more and more and ML want all of the data. They want larger and larger amounts of data. We've actually had data scientists for quite some time. They were called actuaries initially, and I think there's one that dates all the way back to the 1700s, where they simply looked at a set of data and then they used that to make a prediction. What we're seeing, though, is those data scientists are becoming very passionate about getting more and more data into their models because they recognize that that is what improves the accuracy of their models more than anything else. So you have to be able to go after all the data, regardless of its structure, regardless of how quickly it's being generated. You have to be able to process it. And then, of course, the size, the volume of it. Big data is a little bit of an overloaded term, but it really does mean the three V's: volume, velocity, and variety of data. So yeah, I think that more and more we need to get to all of the data. And in fact, I think you'll find that a very small percentage of data is actually structured, especially with the internet. So we need to be able to get to it all and incorporate it into our decision-making process. So yeah, definitely seeing that and more from data scientists wanting larger and larger amounts of data.
Great. Now, shifting the conversation towards efficiency. So, Sanjeev, you had hinted at this. I saw in a Towards Data Science article that 2023 marks a shift in focus to efficiency and the broad adoption of generative AI. What are you hearing? Any recent news that you've heard from any analysts or contacts that you have about the importance or the role of financial cost in data observability?
Clinton, when we started this year, I did a webinar for the Cube, which I do every year with 5 or 6 of my fellow analysts, and we do some predictions for this year. My prediction was how important cost optimization is going to be in 2023. Lo and behold, generative AI just dominated all conversations, and we temporarily shoved it under the carpet. So, but now it's bubbled back up because you cannot ignore cost optimization. It is so important. So I had done a chapter in Data Observability, the Reality book, where Unravel and a number of other data observability companies had all contributed a chapter. So I wrote the last chapter, which said the newest kid on the block for data observability, actually there are 2, data FinOps and data BizOps. Data BizOps is a kind of a weird thing that I thought of, which is observing the productivity of your data. But let's not go there. Let's talk about the FinOps. Now, Gartner has, in the meantime, also come out with its definition of data observability, and now they're on to second version or iteration of data observability, and they've added FinOps into that. So I'm really happy to see that my ex-colleagues at Gartner and we are completely aligned in our definition of data observability, including FinOps. My take on this is that when we do data observability, actually data governance in general, we are working at the metadata layer. So we are taking the metadata of our data objects, which could be technical, like schema and distribution, or we're taking business metadata. FinOps is actually kind of a usage metadata. How effective is that environment where you are running? Are you underutilizing your resources? If so, maybe you should use a cheaper resource. How quickly are you running your jobs? Are they bottlenecked? Do you have the right SQL queries in place? So this is the financial aspects of data observability. So basically now we have converged Gartner and the industry definition. There are 3 major components of data observability: data quality, data reliability, and FinOps. So that's what I'm seeing in the industry.
Fascinating. And Subbu, would be interested to get your take on this. Have you seen organizations in your past succeed with this efficiency aspect, or struggle with it?
No, I think generally everybody struggles. And this was a lot of what I used to do in my previous role was essentially helping our SI partners get to the root of the problem, right? And unfortunately, when it comes to tuning Spark jobs, there is no easy answer. You have to get in there, and it's a very manual, very expert-oriented effort. So that's something where there is a lot of room for us to improve, and I think Unravel fits in perfectly. We definitely go there in the demo. I'll make one more appeal, right? I think as of course, companies need to do cost optimization to save dollars. I'll say this: I think humanity needs to start consuming less resources, right? I mean, we see all this craziness like climate change stuff happening. And with LLMs, it's just getting worse. The energy demands of LLMs are intense, right? I was an article I was reading that Microsoft wants to install nuclear reactors to power data centers, because unless we can blanket the earth with solar panels, there's not going to be enough power. Okay, so
interesting.
So optimize your jobs, use every tool necessary to cut that, and then you'd save dollars in the short term, and of course there's an altruistic payoff in the end, which is you're saving the earth.
I think Subbu, you can get me started. We can turn this from Unravel webinar into a TED talk, because you've really touched a raw nerve. I think we should do another talk, Clinton, on sustainability, because
save the world. Yes.
Cost aspect. Yeah, I think it's really important topic.
Now, Sanjeev, if you have an LLM or generative AI, is that a guarantee of profitability? Like, we're hearing some big name companies out there creating these amazing models. For example, we see things like Copilot. Is that guaranteed to be a success now that they've built it?
No, not yet. But I'm a firm believer we will get there. I feel we are at the same stage when, let's say, printing press came out. So imagine this: what would have happened if we transport ourselves back to 1800s, or whenever printing press came out, Gutenberg, Bible times. Mm-hmm. Do you think a printing press was a success when it came out? I don't think so. How could it be? Who would be the consumer of a printing press product when majority of the people had never been taught to read or write, because there was nothing to read or write? So it would have taken a few decades, maybe a whole generation, before people started reading printed material, because now they were being taught in school. Generative AI, I hear, is it overhyped or not? I think it may be underhyped. And maybe I'm a very strong believer in the force of technology's progress. And who knows? But the fact is that right now people are not productive. I learned something phenomenal. Last week, I was at an event. I met some people from a big pharma company, top 5 pharma company in the world. Everybody knows them, thanks to COVID. So the CEO has mandated every business unit head must have production AI use cases in a short amount of time. And these AI production level use cases cannot be Mickey Mouse ones, like frequently asked questions, summarize it. What this company has done is they bought 10 million medical journals, and they basically want to have LLM go through this and try to find, are there any commonalities between these different documents from WHO, CDC, New England Journal of Medicine, and so on, and help find diagnosis, new remedies, new cures, new medicines, reduce the FDA approval time by half. These are all use cases that will generate an ROI. Are we there yet? No. But are we going to get there? Absolutely. It's just a matter of time. And we're moving faster than we ever expected. Like last year, we wouldn't even be having this conversation. It didn't even this concept didn't even exist. But today it does, and it's moving at a rapid pace.
And Don, from your perspective, what do you think organizations need in order to scale? So as we start to think now about implementing at that level that Sanjeev described, what is necessary to put in place in order for an organization to have that capability to be able to start producing AI models and revenue at that scale?
Well, I think to some extent these observability platforms, because what you can't measure, you can't ultimately control, because you can't determine a baseline and a delta, and so you need to be able to take that holistic view of your ecosystem, and I know that's an overused term, maybe landscape, and take that data and use it to baseline, and then determine, are you able to scale? And if you aren't, where are the problems that you aren't able to scale? The great thing about the cloud is it does build in this ability to scale, but it's not always, like you were saying earlier, it's not a guaranteed win just because the clouds have this ability to scale. You've got to be able to step back and look at things holistically and look at some key KPIs and determine how you're doing and where you're scaling well and where you're not. and then being able to go back and adjust those areas where you're not. I mean, it could be things like resources. You don't have enough data scientists, you don't have enough data engineers, or it could be things like processes. Perhaps your processes are overly burdensome, overly bureaucratic, and that's why you're struggling with scaling. But it all starts with the ability to see what's going on, make improvements, and monitor and measure whether or not those improvements are making a difference. And that's really at the heart of these observability platforms.
Excellent. Subbu, from your perspective, what have you seen organizations who do this successfully at scale do in order to make this repeatable, to make this success happen over and over again?
Great question. I think it's classic process, people, and tools, right? So to me, it is having the right people, number one. You need to amplify their effect, and that's where tools come in, and then training the masses comes in, right? So like a train the trainer model or some sort of enablement mechanism is going to make a difference. I think as a programmer, I spent many decades programming. I'm a lazy programmer. Okay, my first thing is if a tool can do it, let's bring the tool. Okay, so. I over the decades I have a quiver of tools I will go to every single place with, right? So if you ask me to build a data platform, a data estate, my first tool of course is going to be Databricks, right? So that's my first preference. Now of course you got to manage the costs on the lake house and instill confidence, and my second tool is going to be Unravel. No surprise, right? And even within Databricks and Unravel, of course, I mean, this can be its own webinar, but you pick a use case and I will tell you what feature to use and what not to use, what the patterns are, what the anti-patterns are. So long story short, pick the right tools, get the right people. You don't need an army with the right tools, and then build on that.
And then Sanjeev, from your perspective, how do you shift this concept of efficiency left into the developers' mindsets as they're building so that you get ahead of the cost early on? Have you seen companies do this well? Are there any best practices you think should be repeated?
Clinton, that's a great question. Shift left is one of my favorite things to do. And shift left basically is for everything. Data quality, the sooner you find there's a problem, you fix it, the cheaper it is for you downstream. Security, the sooner you fix security, the safer you will be downstream. So same thing for observability. What has really shifted, and this comes down to data culture, is that it used to be we started this webinar, but Subbu and I were sort of converging on this Cartesian join example I gave. At that time, data. FinOps, it wasn't called FinOps, but the whole financial thing was CFO's responsibility. Today, it's everybody's responsibility. Data developer needs to know what is going to be the cost of what they're about to start. And a lot of things, I know you support BigQuery, for instance. BigQuery can tell you before the query runs that this query is going to cost you X amount of dollars. So that responsibility and accountability for fiscal discipline is now throughout the teams. It's no longer just a CFO. It'll be too late. But if the CFO or the finance team is the only team responsible for it.
I'd like to thank each of you for your participation, Subbu, Sanjeev, Don, in this amazing event. And thank you so much for your insights. So let's jump into a demo with Don of the product.
Yeah.
All right,
thanks, Clinton. Well, hello, everyone. This is Don Hilborn, and we'll be talking about the Unravel Data platform today. I'll be walking you through a demo of that platform. If you can imagine what Unravel does for you, I like to draw an analogy between these devices that they have you can plug into your car, and it tells you all the times that you're driving aggressively or you've taken a corner too quickly, as well as it makes recommendations on how you can improve your driving. Well, that's a little bit of how Unravel works. Unravel installs these very lightweight agents into your data landscape. Those agents send data back to the application layer of Unravel, and it organizes that data and passes it through AI and ML algorithms to make recommendations for you ultimately on how you can drive better or operate your data landscape better. And of course, one of the areas that it looks at is cost, and that's what we're looking at right now. Is we're looking at some trends in cost in this fictional environment that I have pointed this to, a Databricks environment in this case. And so you'll see that I can look at cost by a given workspace. I also can look at it based on a range of data focusing in on particular days. But I also have the ability to look at cost other ways. I can look at cost from a chargeback perspective, where perhaps I'm looking at the users of the system, not just the workspaces. And I can see who's using the system the most. And if need be, I can actually drill into that individual user and look for opportunities to make optimizations, where I can look at all the different tasks that they've run within Databricks in this case, and I can focus on, say, one of the jobs that they've run and actually go into that job and look for recommendations, what it's telling me that I should do to make this run better. And in this case, it's telling me that I have a bottleneck, which is a contended driver. And I also have potentially efficient issues as far as my sizing compared to the job that I'm running. Other ways that Unravel helps you control your environment, manage it, make sure that you're driving as efficiently as you can is through budgeting. So you're able to actually define budgets about or around your landscape and then monitor those on an ongoing basis. And in fact, here is another place where Unravel uses its AI ML capabilities to forecast or try to determine what your budget is ultimately going to be. So hopefully it can tell you before you've exceeded your budget by 987% that you're going to exceed your budget. And of course, the hope would be if it tells you enough in advance, you could actually go in and make changes. You could look for particular trends, or you could look for opportunities here again to optimize, where it takes you into a given set of tasks that have been run, a given set of jobs that have been run, and it allows you to drill into them and find recommendations potentially. So here again, we have another bottleneck. You also see that we have some very relevant data about the number of events that we're processing per batch. And in many cases, we can actually go look at the resources that are being used. We can look at the configuration that existed at the time that this particular job ran, and we can look at different aspects of that configuration, look for areas, again, where we might be able to make improvements. We also allow you to look at the actual compute that you're using, and we organize that into all of the jobs that have run, all the clusters that have stood up, or the jobs that have run, those that have finished, those that are running, but probably most important to you, those that we see as being inefficient. And again, we have an opportunity to go in here and it makes some tuning suggestions to us. So we drill down into that. We see we have a contended driver, and we also see that we have some opportunities to make our process run more efficiently. Another thing that Unravel does for you is it actually looks at how you're using your existing data stores, your tables, your blob storage. And probably most valuable is to determine whether or not your storage could be used or needs to be used as the most expensive hot storage, or could you use warm storage, or in some cases, even cold storage? So again, giving you an opportunity to optimize your overall environment, in this case, focusing on storage. There are certain reports that come with the platform, and then of course you can actually build out your own reports. One of the most popular ones is kind of the TopX report. So what are my greatest offenders? What applications are consuming the most of my resources? And being able to look at those, or even schedule or rerun that report. Probably one of our most powerful aspects of the platform is this concept of auto actions. And here we're actually able to go in and based on an event from a job or from a cluster, we can take action. We can send an email. We can also make a REST API call. So we can potentially reconfigure a cluster. We can look at something that tells us that this cluster might not be sized properly, and we could make an AI call to decommission that cluster, reconfigure it, and then start that cluster up again, and then run the job on that cluster. Generally, most of our customers start out treading lightly here with emails, but as they grow more and more comfortable with the platform, they may build out some of those more advanced REST API calls. We also give you this ability to look at the insights in your system overall. So in this case, we'll go back to the most history that we have, which is in July, and then we'll come up to today to kind of look at the most current. And this really gives us a very high-level overview of the cost, the resource efficiency, and then the app usage that we're benefiting from. What are some areas where we, as Unravel, can make recommendations to you to improve your environment? And here we're seeing some of those, where you can go in and you can, again, drill into certain areas, get into the particular job, and then ultimately drill down into some form of recommendation with some very detailed information about that particular run. That's a very high level overview of Unravel. There are other aspects of it that perhaps in another session we could drill into. We have this concept of our app store and something we call Unity apps, where applications can be incorporated within the platform. And then, of course, we have the ability to diagnose our platform as well to help you see how the resources that we're using, which is very minimal, less than 1% on any particular node that we're running on. But it also allows you potentially to connect to other workspaces and do analysis on those workspaces as well. So with that, I'll close out the demo and I'll turn it back to you, Clinton. Thank you.
Well, Don, thank you so much for that incredible demo. Really appreciate that. All right, so now we're going to transition into some Q&A. And Don, if I could ask you the first question that we have from our audience participants here. So this question is about choosing the right architecture. So Don, the question is, if I don't already have an established architecture for my data platform, is there a right answer in terms of the best platform choice?
Yeah, so I think a question I hear a lot is around architecture. You know, what's the right architecture I should implement in GCP, in Azure, or in AWS? And I think one of the things you definitely have to consider when looking at an architecture is, do you have the ability to manage and monitor that architecture? And if you don't, where are the gaps? Because the right architecture depends on the entity itself, what businesses it's in, what particular use cases it's addressing. And to be able to determine if you have the right architecture, you need an observability tool or something that gives you that holistic view of your environment so that you can determine, is this architecture performing optimally for me? given what I need to do with it. So I would say when considering an architecture, there are certainly lots of things to consider. And one of those is, do you have the ability going forward to monitor and manage that architecture?
All right, looks like we have a couple of other questions. So I'll turn the next one over to you, Subbu. Do you mind reading the question before you give the response? Thanks.
So we just got a question from the audience. This is the Databricks Lakehouse question, so I'll take it. And the question was, and I'm paraphrasing here, can you give an example of where Unravel can make a significant difference in optimizing Databricks and Lakehouse? And I'll give an anecdote here. And I, one of the most difficult situations tuning a Spark job is catching data skew, right? And it typically happens when the job runs, and then it comes to 99%, and then it fails at the very end. To catch data skew requires you to click through a bunch of things, and then the symptoms will reveal themselves, right? And then you can diagnose it. Guess what? Unravel, because the two, and then of course, before I go to Unravel, imagine, hundreds of jobs over tens of workspaces, all potentially having data skew issues and performance challenges. And then you begin to get a sense of the scale of the problem. Now, that's where a tool like Unravel will come in handy, because it's monitoring all these workspaces, it's monitoring all the jobs, it's pulling out telemetry, and it will give you, as the issues happen, it will start giving you alerts, which will help you. You can have one expert who's looking at Unravel and then basically fixing things as they happen, which is huge, which will massively save cost and improve time to market, essentially.
All right, we have time for one more question. Sanjeev, do you mind taking the last question? Read that out before you provide the answer. Thank you.
So the question that just came in was, you gave some examples of how to do cost containment for generative AI. Are there any other examples you can share? So one that comes to my mind that I'd like to share is that we've had this concept of caching for the longest time in our data space. Now the same concept exists even in generative AI. For example, if salespeople are always asking the same question in their chatbot, then that question, every time that question does not need to incur a very expensive call to OpenAI LLM. And we also know that it's slow. It takes 10 seconds for the response to come back. We can, if we build our generative AI applications correctly, then when we get these questions and we create a vector embedding, we can compare and see if there's already a response from an LLM, then we can serve it from a vector database instead of making an open AI API call. And these are the things that the data observability products can incorporate. They can discover and intelligently route the queries to wherever it is most cost effective. Thanks for asking that question.
Well, that concludes today's webinar. Thank you so much to everyone who joined us and attended. We'd like to also thank our speakers, Sanjeev Mohan, Principal and Founder at SanjMo, Subramanian Iyer, Unravel Training and Enablement Leader and Databricks Subject Matter Expert at Speedboat, and Don Hilborn, Field CTO at Unravel Data. Thanks to each of you, and we look forward to seeing you at our next event. Meanwhile, be sure to go ahead and sign up for your free Unravel account for Databricks and reach out to us if you have additional questions. Thank you so much.